Broadcast is now starting. All attendees are in listen-only mode.
Welcome, everyone. We are going to wait just a moment for all attendees to make their way into the webinar. Again, it looks like we still have some people coming in here, so we'll give it half a more minute. Okay, why don't we go ahead and get started. Welcome, everyone, to the second session of our Whole Tomato Summer CodeFest C++ Coding Camp. My name is Ben. I am Chief of Staff for Whole Tomato, and I'll be introducing today's presenter and topic, which will begin shortly. So we launched this series as a way to provide short, focused learning sessions that dive into a specific area or topic in C++ development. To supplement or hone your engineering skill set, a couple of days ago, we had an awesome session covering concurrency in C++ with our own Chris Gardner. We had a lot of good content and questions. If you didn't attend that one, I would encourage you to go back and rewatch it once those links are available. Today's topic is what the hex, ports and adapters architecture with C++. We'll be covering hexagonal architecture. But before I introduce our presenter, I want to quickly mention a couple of things. We will have time for Q&A at the end of the presentation, so please ask your questions throughout the presentation. We'll circle back to them at the end. There are no stupid questions. If you're wondering about it, someone else probably is as well. So go ahead and ask it. We'll answer as many as we have time for. We will be moving through these slides quickly, so if you miss something or you want to refer back to something, our slides are available as a virtual handout in PDF format. You should see that link in the GoToWebinar handouts panel. If you're wanting to see our other Summer CodeFest sessions and topics, we'll have 4 more following this one. We will provide you with the schedule and the registration links so that you can make sure that you're signed up for those. These webinars will be recorded and made available for rewatch, so if you need to drop or you want to circle back to something, you'll be able to, and we'll send those links out to all registrants after our webinars conclude. This webinar, all of these webinars are sponsored by Whole Tomato. We published the highly popular Visual Assist extension for C++ and C# development in Visual Studio. If you're not already using Visual Assist, I would be remiss to not mention that we do have a free trial available. You can get it on the Visual Studio Marketplace, or you can download it directly from our website at wholetomato.com. Also, we've just launched a new academic program for Visual Assist, fully sponsoring schools, universities, and even online coding camps to make Visual Assist available to both instructors and students. So if you're in the educational world, either as an instructor or a student, and this sounds like something you'd be interested in, please reach out to us. Send us an email at sales@wholetomato.com, and we will be happy to get the process started for you. We're eager to partner with educators and bring more high-powered C++ developers into the industry. All right, so I'm sure you're ready to get into today's topic. So it's my pleasure to introduce to you Nuno Castro. Nuno is a product manager for Embarcadero's RAD Studio. He's also a proficient C++ developer. He began programming C++ back in 2010, and I asked him what he enjoys doing the most with C++, Interestingly, he said embedded systems. So think of things like sensors, collecting data, small electronics, and gadgets. So he's well versed in today's topic. Nuno lives in beautiful Lisbon, Portugal. And when he's not coding, you might find him out on the water on a surfboard or on the paddle court. He's got a lot of great content, and I've already taken too much of his time. So Nuno, please go ahead and take us into today's topic.
Thank you, Ben, for the presentation, and hello, everyone. Welcome to today's topic. I'll be disconnecting the camera so you guys can focus totally on the content, and I'll put it back in Q&A. So before we get started, I just like to give some heads up to some additional resources, especially for these three people. So Valentina Kupak, she has an awesome YouTube channel where she talks about hexagonal architecture deeply, and their resources are very good. I really recommend you to have a look at it. Also to Alistair Cockburn and Juan Manuel Guerrero de Paz. Alistair is inventor of hexagonal architecture itself, so make sure that you pass by his website and also by Juan's website, as they talk about these topics extensively and in a lot of detail, so you will benefit a lot from looking at these resources. Also, here's the link for the original article for the hexagonal architecture. It's a very nice read, so if you have time, some time to spare, maybe over the weekend, have a look at it. It's a very good article. So for today, what we have, and at the end of the session, we will be able to answer all of those three questions. So how did we end up here? And why bad architecture happens, and what is exactly hexagonal architecture? So to get started, let's talk a little bit and give you some context first, a brief story on software developers. So I don't know if the audience knows, but for those who don't know, Ada Lovelace's programs for Charles Babbage's analytical engine were the first things considered as software development. So at the time they are trying to do so, this analytical engine was proposed to be a computer. So it will have conditional loops, it will have if statements, and they were trying to make the first personal computer. However, and the piece of software, or the programs that Ada wrote, were actually considered the first tries to do computer software. However, their work remained purely theoretical, and they did fail to create the personal computer. And only later, with Alan Turing, in 1935, that he was the first person to come up with theories of software that then lead back to the field of computer science and software engineering. And also, I don't know if you know, but for example, Fortran was invented late in the 50s, and COBOL, it was first conceived in 59. And I'm mentioning all of that just to make the point that software development is less than 100 years old. If we count from 35, it is 88 years old. So it is a very recent field, actually. And I looked online, and I've looked into some surveys on how many software developers there are out there. I found a few answers, but something in the rounds of 20+ million software developers. I'm not sure exactly if that's true or not, so I didn't share the links here, but let's assume that we are millions of developers today. And the question is why is this relevant to software architecture, actually? And if we think about it a little bit, and if we look around us, our society and our world is built in a way right now that we depend a lot on hardware and software. So just in my field of view, I can see my cell phone, my laptop, I can see a TV, I can see that I'm looking at my kitchen, I can see the microwave, I'm hearing an airplane passing by, and there's a ton of software inside, and a lot of critical software actually inside of an airplane that can really put in danger people's lives. So all of this infrastructure that we created to rely on was written, the software that there was written by a person like us, software developers. And this created a huge demand for software developers in the industry, and we can consider almost every company these days a tech company, and that's because even if your main operation is not itself based on software, it will have some kind of software behind helping you do the operation. And this high demand that was created made people from all over the field try to switch to software development, because there was a promise of high salaries and maybe working remotely from Indonesia while learning surf on the weekends or after work. So we are seeing a phenomenon of, for example, I have seen people from medicine coming to software development, people from law coming from software development, people that didn't add any degree, for example, coming to software development. And normally what they did is they would go into a 3 or 6 month crash course, and they will learn the latest, new, coolest technology there is to offer. And there's nothing wrong with that. However, normally those frameworks, they are very opinionated and they tell you a way of doing things. So inevitably, software that all of these new people coming to industry will be based on the assumptions of those frameworks. And oftentimes that leads to a kind of architecture that's very easy and very quickly will get out of hand, and then very difficult to manage and to build things upon it. And if you think a little bit about it even more, it's since this field is so new, people with 5 or 6 years of experience are being considered senior developers or architect developers, and then are teaching others to do the same. And I do believe that this is an area where seniority is still very young and we still have a lot of ground to cover. So it would be good to spread as much as we can software architecture, because this really matters, and we will have a better role if we have good, reliable software. And as an example on how things could go back, I always like to imagine this project that I call the Titanic project, because it's brand new, but then the iceberg will come, as you will see. And it normally starts something like this. So you are in a company and they are doing their day-to-day operations, and some kind of new area, some field is starting to come up. But everybody that is senior is busy. So someone asks, so can the intern do that? And of course, that someone will reply, yes, it should be a nice project to get him started. And that goes on, and the intern will do the project. However, 3 years later, the same guy will ask, so why the hell do I have all the customers calling me? And the answer is, our system is crashing, and we are trying our best to fix it. But the developer that wrote the code is not here anymore, and the team says that the code is a big ball of mud. And probably some of you also pass by this situation, as normally these days I see a lot also some new developers come into a company, they are young or they just learned and they are new to the job, they stay there for 1 year. As they get a little bit of seniority, they leave to other places because they will get a better salary or something, they change, leaving behind a mess of spaghetti codes with bad architecture. And as you might know, one of the most difficult things in software architecture is looking into other people's codes, especially if it is bad written and with a bad architecture. So a big ball of mud is just a metaphor used in software architecture to describe a system that lacks clear architecture and has become a tangle of resources of poorly structured components. So if just a quick reminder. And now to enter directly into the topic of this talk, so is how can we avoid this big ball of mud? So for this, I'll try to use a simple example. So let's think that we have a car workshop company that is hurting because nowadays everybody do their bookings online and they still do it manually. So to get started, they want to do something very simple. They want to do an application that has minimal business requirements, that will be listing available slots, book a repair, and cancel a repair. And since this is very simple and mostly crude, we can do manual testing, easy to get started. you will choose to go for an MVC application, model view control application. It's very easy to get started. You have frameworks that will put the entire boilerplate up front to you. You go with it, you are super fast, everybody's happy, and you have your application up and running in no time. However, as normally happens, when you have something working and it works well and fast, people start asking for more things, and edge case starts to appear, and new business rules are required, and new features. And then the stress starts, the business logic starts bleeding everywhere. Additional, you add automated UI testing because now there are so many business logic tests. Manual testing is taking a lot of time, so you try to automate, but the only thing you can do is UI test because everything is messed up in your controllers and models and views. The system becomes hard to change. And on top of that, they say that they want to integrate third-party system because there's a big company out there that let people search for car repairs in their system and book repairs. So we want to integrate with them. So we do that. And we were scared. So we talked with a friend of ours that is in the field for a long time. And he suggested, okay, what you should go is for a 3-tier architecture, because then you could be able to have the presentation tier separate from the business tier and the data tier. Everything will be very well organized, and you'll be able to integrate third-party components without any problem. So it's a good excuse for you to sell in the company because they told that they want to integrate a third-party system, and they didn't tell you about it, but now the deal is closed. So you can sell out the idea that the application needs a major refactoring, and that's what you do. You'll do the major refactoring, you'll go to the 3-tier architecture, and now you can test your UI and business logic separately, so very nice. You can integrate the third party without interfering with your own system, with our own UI. Unit tests are easy to do, and everybody's happy. However, now that everything is working properly, financial people are saying that, well, if we are automating the business, we also want to automate our accounting. So maybe we can have our system communicating directly with our legacy system that needs to be integrated. And we will do that because now we have the 3-tier architecture with everything very well separate. So easily we integrate our legacy system that is even written in some old technology and communicates over FTP or XML or SAP or wherever it was, no problem for us. However, as time is passing by and you need to add more features, you will notice that once again, your business logic is bleeding into several presentation layers. The business, and this is why, because the business logic is fully exposed, and with an architecture like this, your presentation layer actually has access to all the internals of your business layer, so they can start invoking methods in classes that they are not supposed to, and you start to do some tricky things because you suffer from pressure, then you need to deliver on time, and this is the easier way, and you go for it. And as time passes by, unit tests starts again to be harder to do. And now on top of that, other providers want to integrate with us. So what we will do, easy. So we will add an interface in between the business tier and the presentation tier, and it will be an interface API. And this interface that in C++ can be implemented with an abstract class will be basically the interface that has the use cases to communicate with the application. So basically, the business tier will then implement the interface API, and the REST API will use the interface API to communicate with the business tier. And like this, so we only expose what we want, we have a clearer separation of concerns, and we can add as many external systems as we want safely. And everybody is happy. However, now clients are starting to complain that the app is slow when we are looking for available parts. And let's say that this is because maybe our database is hanging or something like this. So what we can do is, and what we notice is our ORM is tied to our data layer, and their business logic is actually leaking into our data layer. And since we notice this, we want a faster DB to retrieve available parts fast. So maybe we'll want to an Elasticsearch DB or go for Mongo or any other thing. So what we can do in this case is add another interface for the data layer that is a repository API that will do the mapping of what the business tier needs from the data layer. However, then our data tier can implement this API and we can use anything below that we want. Our business tier doesn't need to be tied to any specific kind of infrastructure. This only needs to be tied to an API that we commit to do our operations in the database. And with this, we have a clear separation of concerns. We have our business logic fully protected from implementation details, and we can test each layer separately. We don't have to commit to any given framework, and it is loosely coupled. And notice here that the key is actually in the inversion of control or dependency inversion in the business tier for the interface and the repository API. And this is what we call actually the hexagonal architecture that we'll go in further detail now. So first of all, hexagonal architecture. So why an hexagon? And this is some of Alistair Cockburn's reasons. Alistair is actually the creator of hexagonal architecture. And his reason is with an hexagon, you have enough space for drawing ports and adapters as you need. So that's one of the reasons. And the other is the shape should evoke the inside and outside symmetry rather than top and down or left and right. So square, pentagon, hectagon, octagon, all out of the way. Or square is not suitable. The others are very hard to draw. So hexagon was the winner, and yay, so hexagonal architecture. And in hexagonal architecture, what Alistair says is at the center is what he calls application. It's our core. And in application is where our business logic rules. And our business logic in this center is not dependent on any external resources. This is key. It's not dependent on any frameworks or any device or anything. It's completely technology agnostic and should be implemented with just pure language stuff that we normally have when programming on that language. And also another important topic is hexagonal architecture itself doesn't say anything about how you organize your core, your business logic. So actually, if you want to have entirely spaghetti code inside, it's okay in terms of hexagonal architecture. I don't recommend it to you though. I would go for something maybe like a domain-driven design or some other concepts of clean architecture or another thing. But hexagonal architecture itself doesn't say anything about how should you structure the internals of your application. You can go for fixture or components or divide it in any way you want. So why ports and adapter? Because this is the other name that we have for hexagonal architecture. So ports and adapters because, and starting with ports. So ports is what connects the application with the outside world. And you can see they live in the boundary of the hexagon. And they are normally implemented as interfaces or in C++ abstract classes. And on here on the left side, we have the driver side. And on the right side, we have the driven side. So, okay. So on the left side, the driven side is the side where people can put input into the application. So connected to these ports, we will have adapters. And the adapters are the complete implementation of a given port. So for any kind of port that we have, you can connect any kind of adapter. So it could be a command line interface tool, it can be a test framework, it can be something like Kafka or RabbitMQ, could be a REST controller, anything. You will have these adapters on the right side that will be the thing that brings input into the application. Then the business logic will do whatever it has to do. And if it requires to talk with the outside world to do other things, for example, you will have the driven side with driven ports where we will communicate, for example, with external databases or email services or anything. So notice here that very important is that the application itself communicates to the means of ports that are abstract or they are interfaces that are defined by the core itself that then outside people from the world will have to adapt to it if they want to communicate with the core. So our core will always be very well protected from change. and actually can be used with any kind of adapters in any situation, as it will not be affected if, let's say, tomorrow we decide to change our entire HTTP framework. It should be no problem for us, because all we have to do is implement that new adapter in that new framework, as long as we stay coherent with the driver parts. Okay, so besides adapters, we will have actors. They are not represented here, but you can imagine them talking with the adapters. And these actors is actually the people or the devices that talk, are the real things that talk with the application. So it could be someone using a cell phone, or it could be other hardware calling another system. So it's the real things that interacts with the application. Okay, so now one crucial part that I want to talk about hexagonal architecture is inversion of control. So why inversion of control is the essence of hexagonal architecture? Oh, pretty simple, because we use it to actually protect our core, our business logic, from anything else outside of it. And since we don't pollute our core with all of the things outside of it, changes in the system are easier to do, and our business logic stays very clean, even when time is passing by. And even with changes, new technology, new stuff, we can always add to it without affecting our business logic, because remember, it is implemented in pure, let's say, C++ or any other thing, and is not depending on any other system. And an example that we could say to how to use the system, it will be, let's say, if we use our car workshop and we want to book a service, we would have, for example, someone that will use a cell phone, and that cell phone will then send over HTTP to a driver port that we will call bookings API. So it will communicate to the bookings API, say, make me a reservation for tomorrow at 10 a.m. Our business logic will do all the verifications and validations and stuff, and it needs to communicate with afterwards. So to a driven port, it will then send a message with the information to an external email service. That external email service will just send the email for us, give the message back to our application. Our application will give the message back to our adapter, and you'll finally receive in the other end the message saying your booking, or we will receive the email saying your booking was done. So this is an example of how you use hexagonal architecture. And this inversion of control is what allows us to have this core very well separated from everything, and have this plug-in architecture where you can plug in stuff very easily. And notice that from left to right, so the driver side and the adapters will use it will be a using relation with the driver port, while inside the hexagon, the application will have an implement relation with the driver port. So basically, all our business logic inside the application will implement our abstract class, while the driver adapter on the left will use our driver class, but on the right is a little bit inverted. So our application will use our driven port, but then our implementation will implement the driver port. And this is how we can communicate with our application and make sure that it will work no matter what. So some key takeaways that I would like to take you guys to take from this presentation is good architecture can actually save people's lives. A good example will be the space shuttle that went wrong because the metric system was different from other people. And when the time came by, it went very wrong. So all is free for good architecture. So inversion of control is what allows us to isolate our system. And hexagonal architecture allows us to better test our system. With hexagonal architecture, very easily you can plug in tests to very specific parts very easily. You can test just your business logic. You can test just your adapters. So it's very easy to test everything separately. And there is no silver bullets when coming to architecture or anything in software development. Over engineering brings unnecessary complexity. So make sure you only use it if it makes sense. And I would say that, for example, projects that make sense is enterprise projects or large projects, if you are doing something small or experimental, maybe the complexity that it brings is not worth it. But definitely for medium projects or large enterprises, it makes a lot of sense. And some more references about this talk. You can guys then see on PDF the references. Feel free to navigate and look. All of these materials talk in these matters extensively, so feel free to navigate them. And now, Q&A time. Feel free to ask any questions. I hope you guys enjoyed the session.
Awesome. Thanks, Nuno. We do have a couple questions here. So back when you were discussing the driver-driven sides of the application, can you explain what is a fake implementation on that diagram?
Yeah, sure. So basically, a fake implementation is what we will use to test the system. So instead of having the real DB implemented, you will use a fake. So you can run your unit testings without having an actual database that maybe will be slow on performance and such. So you will use a fake.
Got it. Thanks. We also received a question back when you were discussing the MVC app. Shouldn't it be connected to the REST API?
No. So the MVC app here, we are talking about, for example, a Rails application that will have server side running and stuff, and the REST API is separate from that.
Okay, thank you. How are actors related to ports?
So actors is actually the people, or for example, actors are the real people that call stuff. So they are not really related to ports. They are related to the software that writes the adapters. So for example, me, if I'm using a mobile application that will talk with my core, so that mobile application will be implementing an adapter that will allows me to talk with the core. And me, I'm the actor, I'm interacting with the phone directly. So I'm not connected to the ports directly. I'm connected to the device that has the codes below to talk with the ports.
Got it. Thank you. Can you explain a little more what driver and driven mean? Is the driver coming from the UI or the user? Is it a part that does something, or whereas driven is where it gets data or has business logic?
Okay, it's just naming actually. So a driver is because it's on the left side is what drives the application. So is what sends the inputs, it's what uses the use cases. And driven is because it's the application that needs to use something. So it's driven to use an infrastructure, DB and stuff. So that's basically naming, because on the left side is what drives and on the right is what's used. So driver driven.
Got it. And then is a port an interface? Are they the same thing?
Actually, yeah, ports are interfaces, or in C++ abstract classes that then will be then used or implemented depending on where they are situated.
Okay. So here's one. Someone says this all makes sense, but why hexagonal? It looks like there are two sides, driver and driven, or uses and implements, not six.
Okay, so there's a slide talking about it for no particular reason exactly. I can go back to it. Here, so there's no particular reason actually. So Alistair, the guy that invented hexagonal architecture, he said that basically the hexagon is what have enough space to drive a lot of ports and adapters around it. And he wanted to evoke the inside and outside asymmetry rather than top down, left and right stuff. So square not suitable, pentagon, hectagon, octagon, hard to draw, hexagon is the winner. So there's no particular reason actually for being an hexagon. I guess it just He just fell for it. He just felt it was the nicest choice.
So a couple questions about examples. Do you have any examples of code that the hexagonal architecture would be written in? Maybe there's an online example somewhere. And then also, are there any C++ libraries for this, particular stud classes or other libraries?
Okay, so there's a lot of examples online. I don't have an example at the moment, but if you guys like the session, feel free to reach out and we can do another session, just codes. I will bring an example and we will navigate through the codes together, and I will explain all the layers and all the things in codes. And I haven't seen any libraries or frameworks to implement hexagonal architecture. I think it will be hard because this is more of a concept, but not something I'm aware of.
Okay. So can adapters communicate with each other?
Not really, they shouldn't.
Okay. So you plugin architecture, you mentioned. Can you give some examples of that, or talk about some software that does that?
Why should it be hard with C++? So adapters are basically, let's say, if you have some REST controllers, a REST controller can be an adapter. The only difference here is this adapter will have to use, in this case, I can go back. So the adapter will have to use the driver part to invoke the business logic inside the application. But you can write your code as normally as you want, but then with dependency injection, you will inject actually the driver part with the actual implementation, and that's just it.
Okay.
One thing that maybe I can add is there's one element missing here that is called the composition root. The composition root works more or less as a main, and is the only element that is aware of everything that goes in the system, and is in this place where you plug things together. So if your application starts in the composition root, is where you will create all the instances, you will do all of your injection into the adapters and stuff, and there is where all these mechanics will get together.
And that was a composition root, you said?
Mm-hmm. Yeah, it's a name.
Got it. Okay, question about dependency inversion. Can you talk more about abstraction or injecting mocks? This ties in with the fake implementation.
Sorry, can you repeat again the question?
Talk more about abstraction as it relates to dependency inversion.
Okay, so basically we use the normally the flow of an application is tied to, let me go back here, it's easier. So normally the flow of an application is tied directly to this source code flow also. So for example, if in the presentation layer or in the business ledger we include something from the business and the business something from the data, then the flow of application and the source dependencies will not follow along, and sometimes we don't want that. An example would be, so in the presentation layer or in the business layer, we don't want to be polluted with things from the presentation. So what we will do is we will, in the middle, we will add an interface, and on that interface that will be implemented by the business layer is where we will have our use cases, and then our REST API and our stuff will use that interface. And with this inversion of control and with this inversion of dependencies, now the business layer is not more tied to the presentation layer, it's tied to this interface. And with this, we can have a better separation of concerns, and we make sure that any of our adapters, in this case of any of other presentation codes, will not know anything about the internals of our business layer.
Okay, thanks for clarifying that. Another question about an example of use of a hexagonal architecture implemented in C++. We'll take that offline and then talk to Nuno about maybe including an example or pointing to an example in the ensuing blog post for this webinar.
Yeah, I can definitely make a short example, and I'll post it on GitHub, and then we can send to everyone offline to have a look.
Oh, that'd be great. Thank you. Someone asked, one of the strengths of this looks like it can use a mix of elements coded in the same C++ solution, as well as invoking applications outside of the solution. Is that a correct understanding?
Could you repeat the question? I'm not sure exactly if I understood it.
Sure. So one of the strengths that appears to be inherent to hexagonal architecture is that it can use a mix of elements that are coded within the same C++ solution, as well as invoking applications outside of the solution.
Yeah, exactly. Actually, if you imagine, for example, you can have, if you imagine a lot of hexagons put together and touching each other, each hexagon actually can be one application, and then they are communicated with each other as several different hexagons. So you can have all of our things separate and very well structured.
Yeah, brings to mind the image of a beehive honeycomb.
Yeah, exactly that.
This is a good question. Is there a case to refactor 3-tiered legacy applications to move to a hexagonal architecture?
Yes, there is. Actually, if you go to Valentina's YouTube channel, they have a coding session there where they do exactly that. So feel free to, the code actually there, I guess it's in Node.js, but you should understand the concepts pretty well.
Great. A few questions, just so everyone on YouTube channel, please make sure you're subscribed to that. If you go to YouTube and search Whole Tomato, you should find us pretty quickly. You can subscribe and then be notified as soon as these are uploaded. It looks like we've covered almost everything, almost all the questions thus far. So any last questions? Okay, looks like we just had one come in. Oh, so this is a comment. That's another thing that polygons higher than 6 sides cannot do. Hexagons are the highest polygon that can be uniformly arranged together without gaps. That's an interesting comment and an astute observation. So yeah, I think we've gotten through all of our questions. So we can wrap up the webinar now. Nuno, thank you for the presentation and for all the work you put into the slides and the content. Really appreciate it. Thank you to everyone who has attended. Again, we will send out links to our recordings. Make sure to subscribe to us on YouTube. And hopefully we'll see you all again in our next webinar, our next session next week. Thanks, everyone.
Thank you. Bye.